Problem number 10 on part 2 of the fall final review. The factors of negative 9 are negative 1 and 9, negative 3 and 3, and this pair right here would add up to equal 8. Since this is 1, I can use my shortcut factoring. This would be x minus 1, x plus 9 equals 0. Those are my factors. They are not my solutions. X minus 1 equals 0. X plus 9 equals 0. Solve both of these small equations. X equals 1. X equals negative 9. Those are my solutions. The factors of 42 is negative 1, negative 42. This is positive 42, so the signs have to be the same. This is negative, so I'm going to need some negative numbers, and so 2 would be negative 21, and negative 6 times negative 7, and that's the pair that I'm going to need. The factors will be, and to solve them, you put them equal to 0 and add 6 to both sides. Add 7 to both sides. The next one has 4 terms, so you make 2 groups of 2. The GCF here is 3x. The GCF here is positive 2. 3x factors out, and that would leave x plus 5. And so you factor the 2 out, and that would leave x plus 5. The common factor is x plus 5. So you factor it out. The factors are x plus 5 and 3x plus 2. That is not the solution. For the solution, x plus 5 equals 0 or 3x plus 2 equals 0. Subtract 5 from both sides. Subtract 2 from both sides, and then this one has an additional step. Four terms makes 2 groups of 2. Let's see, it looks like 3a will factor out of that, and the only thing that will factor out of those is a positive 1. So, factor out the 3a, and you get 5a minus 3. I see a common factor of 5a minus 3, 3a plus 1. That is your factors. It is not solved. 5a minus 3 equals 0. Add 3 to both sides. Divide by 5. Subtract 1 from both sides. Divide by 3. Since this is not 1, I'm going to have to use my long factoring, multiply the first number times the last number, and write down the factors of 40, 2 and 20, 4 and 10, 5 and 8, and so this pair will add up to get 14, and so I need to do the long factoring. This has a GCF of 4x. This has a GCF of positive 5. So I factor out the 4x, 2x plus 1, factor out the 5, 2x plus 1. So the factors are 2x plus 1 and 4x plus 5. 2x plus 1 equals 0, or 4x plus 5 equals 0. Subtract 1, divide by 2. Subtract 5, running short on room here, divide by 4, on this one over here, multiply the first number times the last number, and so I negative 1 and 12, negative 2 and 6, negative 3 and 4, negative 4 and 3. Oops, that's the pair I need right there. 2x squared minus 3x plus 4x minus 6 equals 0. This has a common factor of x. This has a common factor of 2. Factor out the x, and you get 2x minus 3. Factor out the 2, 2x minus 3. So we have 2x minus 3 times x plus 2 as our factors. 2x minus 3 equals 0, or x plus 2 equals 0. Add 3 to both sides. Divide by 2. Subtract 2 from both sides. And there are my two answers. Before I can solve this quadratic equation, I need to distribute first. In order to solve a quadratic equation, it needs to be equal to 0. So I'm going to add 2x and subtract 32 from both sides. And I'm going to see if it will factor. The factors of 32 are 1 and 32, 2 and 16. Let's see, this is going to be a negative, negative 4 and 8. That will work. Since this is 1, I can use my shortcut factoring. This is factored. It is not solved yet. X minus 4 equals 0. X plus 8 equals 0. X equals 4. And x equals negative 8. Before I can solve this quadratic, I need to distribute. To solve this quadratic, it needs to be equal to 0. So I am going to subtract 8x and add 28 from both sides to both sides. And then I'm going to write down the factors of 28. Let's see, that's a positive 28. Negative 2 times 14. And so that pair would be the pair that would work. Since this is 1, I can use my shortcut factoring. Those are my factors, and so I set those equal to 0 and solve them. X equals 2 and x equals 14.